Hello everyone, this is Tarun from Testing Gyan. Today we are going to discuss a very important and very commonly asked interview question, which is check if the given array is sorted or not. We will be verifying the sorting in increasing order. Okay. Now let us first understand the problem. The problem is very simple. We are going to verify like given array is sorted or not. So I'm having few examples here. Like here we can see the first array having the elements 1, 2, 3, 4. So this will return the output as true, that is this array is sorted in increasing order, that is 2 is greater than 1, 3 is greater than 2, 4 is greater than 3. Likewise, in the next example, I am having only one element which is 1. So this will also return true because single element array is also considered as sorted array. Then in the next example, we are having elements as 1, 2, 2, 3 and 4. Here we are having duplicates, that is 2, which is repeated 2 times here. So this array is also considered as sorted because we will consider the duplicates here, and 2 is greater than 1, 2 is equal to 2, 3 is greater than 2, 4 is greater than 3. That is the increasing order is also maintained. And in our last example, we are having 3, 2, 1. This array will return false because this is sorted in decreasing order and we are verifying the sorting order for increasing order. Now we will discuss both brute force and the efficient approach. So let us first discuss the brute force. In brute force approach, we will be simply picking one array element at a time and then we will compare it with the rest of the array elements. Like if we take example here, if we take array as 1, 2, 3 and 4. Okay, then we will pick one first and then we will compare it with the next array elements, like 1 is compared with 2, 1 is smaller than 2, then 1 is smaller than 3, 1 is smaller than 4. So that means this array element is present in sorted order. Then likewise we will repeat for the next array elements. Then we will start with 2, 2 is compared with 3, 2 is compared with 4 and it is smaller than both of these, so 2 is also present in the sorting order. Similarly 3 is compared with 4, 3 is also present in the sorting order. Then at last 4 is already, it's a single array element, so it will be in the sorting order. So like this we can compare all the array elements and we can see if the array is sorted. Like if we have, let's say we had some input like this, 1, 2, 4 and 3. Then in this case for 1 it will work efficiently, like for 1 it will be okay, 1 is less than 2, 1 is less than 4, 1 is less than 3. So similarly for 2 is less than 4, 2 is less than 3. But when it comes to 4 is less than 3, which is false, and this will return the output as false. So this is our brute force approach. Now the problem with brute force approach is like we will be using two loops. One is to pick the array element, second is to compare it with the rest of the array elements. Okay, so the time complexity in this case will be big O of n square, and the space complexity will be big of 1 because we are not using any extra space. Okay, now we should reduce our time complexity because this complexity is very high. For the smaller inputs it's okay, but if we have large inputs with array elements like in thousands or something, right, or more, then in that case this can be a very bad situation. So we should improve this. So how we can improve this? We should reduce the time complexity. So here comes our efficient approach. In our efficient approach, we will start the traversal from the second array element and we will compare it with the previous array element. Okay, that is, if my input is array 1, 2, 3, 4, then in this case we will start with 2. 2 is compared with its previous array element. 2 is greater than 1, okay, which is expected behavior, so this will return. So this will move on to the next iteration, where then in the next iteration 3 is compared with 2, okay, which is again true, expected behavior. Then in the next iteration 4 is compared with 3, that is again. So our motive here is to perform the comparison in single loop instead of two loops. Okay, so as our array, we already know that our array is sorted in increasing order. Whatever array is given, it should be sorted in increasing order. Okay, so we will take advantage of that and we will pick the one array element at a time and compare it with its previous array element. That is, if 2 is greater than 1 true, then the next array element should should be greater than 1. Okay, and we will compare it with its previous, which is 2. So it is again true. Then we will move on to the next array element. So this way we will say that our array is sorted. Now if we take the another example, which is 1 2 4 3, in this case 2 is greater than 1, expected behavior. 4 is greater than 2, expected behavior. But 3 is greater than 4, this is false. Okay, so here in this case our output will be false. Okay, and we are doing this complete operation in single loop. Okay, we will see the implementation just after this. So in this case, time complexity changes to big O of n, and space complexity, as we are not using any extra space, so it will be big of 1. Now let us see the implementation. Okay, so our first implementation is the brute force. Okay, brute force or the naive approach. Here we can see, right, we are having is sorted naive method, and we are having the input array as an argument. So the first thing which we did is find out the length of the array. Okay, now then we started the first loop. Okay, in the first loop we will be picking up the array element. Then we started the second loop. In the second loop we will be comparing the picked array element with the rest of the array elements, that is the elements which are coming next to it. Okay, so you can see we compared array of j with array of I. Okay, at any point if array of j, that is the next array element, is smaller than the previous array element, then it will return the false. Okay, in case if it is not, then we will at the end, with after the complete traversal, we will be getting the result as true. Okay, so this operation is using two loops. One is to pick the array element, second is to compare it with the next array element. So that is why the time complexity is big of n square, and the space complexity is big of 1 only, because we are not using any extra space here. Now let's move on to the efficient approach. As discussed in our efficient approach, we will be picking the array element and compare it with its previous element. So that is why our iteration starts from the second array element. That is why int I equal to 1. Okay, so here we can see the picked array element is compared with its previous array element. Okay, that is I minus 1. Okay, and if at any point if the picked array element is smaller than its previous array element, then it means the array is not sorted, it will return false. And if if we are not getting this situation, then it means array is sorted and it will be returning true after the complete traversal through the array elements. So this is the very simple implementation of both the approaches. So if we run this program, you can see we are having the single array element. So in case of single array element in our efficient approach, if we see, this will not even enter to this for loop, this will simply return true. Okay, because we know single array element is always sorted, that is array with single element is sorted. So let us run this. So you can see both the approaches are giving the output as true. Now if I change the array to like 1 2 3 and 4, so this is also an sorted array. In this case also we should get the output as true. So we are getting true as the output. Now let me change it, let's make it 2 again. Okay, now if I run it, so you can see we are getting the output as false. Now let us also verify the scenario where we are having the duplicates. So we are having 2, which is a duplicate array element. So if I run it, it's returning true because it's present in the sorted order only, that is increasing order. So I hope you guys understand the problem, its solution, and the implementation. In case you have any problems or queries, please let us know over the video comments. Thank you.